Right, so hello. In this video we will be taking a look at how you can move the Tetris piece across the board. It automatically moving down. You can even speed it up when pressing down, and when you press up you can rotate your piece. So this is all we will be looking at in this video. So let's get right into it. Right, so before we get started with some functions, we want to make sure we have all of our variables set up. First variable we have is the movement directions, or const I should say. Then we have the fall timer. Then we want to set a fall interval, which will basically be the time between automatic downwards moves in seconds, so this will be 1. And then we want a fast fall multiplier, which will be used when we hit down on our keyboard, which will basically speed things up when actually dropping the block or tetromino. Then what we can do is we can actually already go into our function here, the process. Now we want to rename this to the physics process because this will be used for the tetromino logic handling, which is basically detecting player input. So we want to start off with actually setting our movement direction into a variable. So we'll just do this. We want to just make it 0 for now because we will not actually do anything with it yet. We will change this when we actually detect the inputs, which we will do right here. We'll start with UI left. So that will basically mean when you hit the left key on your keyboard. Then we want to make sure the move direction will be set to the left, of course. Then in an else if, we want to check if the action was the UI right. So if we press the right key, then we obviously want to set the direction to the right here. Then we also want to make sure that our direction won't be 0 after this. So we want to make a check here to check if it is not 0. Then we can actually implement our method or function here to move the tetromino into the direction we want it. So like that. And then the last thing we want to do inside of this function is we want to handle the rotation. So we will be binding this to the up key or the up arrow on your keyboard. I will show you how to actually change this if you want to use other controls in just a second here. This will be another function we will create, the rotate tetromino. And then we want to make sure we actually use our timer that we made here. So we want to set the interval to the fall interval before we get started here. And then we want to check if the input is down. So that way we actually just speed it up if it's pressed. Then we want to set the current fall interval and divide and equal it by the multiplier. And then we want to make sure we actually set up the timer properly. So to do this, we can simply go ahead and add the delta to the fall timer. And then we want to check if the fall timer is less or equal than, or greater or equal than, the current fall interval. And we then just move the tetromino down. There we go. And then we want to also reset the timer so it does it again on every click. So then I'll actually show you how you could use different inputs if you wanted. So what you can do is you can come to the project settings, go to input map, and in here we can add different actions. So if you want to do something like move right, you can click add. Then you can actually go ahead and click on the plus sign here, and you could, for example, use the D key, right? So then when you do this, it will only use the D key to move right. Now, in a case where you want both the D key and the right arrow, you could simply add another one and do the right here, so the right key. And then this way you have both the D and the right key set up to handle your movement to the right. But we will not do this in this tutorial because that's just going to take a bit more time, and I'll just make it straightforward. So let's get started with moving the tetromino. So let's go down to the bottom here and we'll make the move tetromino function. I've been writing a lot of TypeScript lately, so I need to get used to the arrow again with the minus instead of the equals. So in here, what we want to do, so we want to first check if it's a valid move. I'll explain this when we actually get to that function. But it pretty much makes sense, right? We want to first check if it's actually a valid move and we're not colliding with the walls, or we're not colliding with any other obstacles in our way before we actually make the move. Then the current position will be our direction, and we want to re-render our tetromino with these new variables. So we want to re-render the active tetromino on our current position and the correct piece atlas. So then let's get started with writing these actual helper functions here. So we'll do the isValidMove first, which will take a new position, or this should actually return a boolean. So then what we want to do is we want to check every single block inside our active tetromino. And then what we basically want to do is we want to check if it is within bounds. So this will be another helper function we make here, plus our new position. Then we want to return false if this is not the case. And we'll return true if we actually do have a valid move here. So let's make the actual within bounds function here is within bounds, which will take a position and will also return a bool. Now in here we want to check some variables. I'll write it out and then I'll just explain. So this basically checks if the block is not colliding with anything. We basically check for the position and we check if the columns +1, because we actually have our grid set up to where it's 11 by 21 because of the walls. So we have to add the 1, otherwise we would miss a block to check. And we basically do the same for the rows, so then we can see if it's actually colliding with another part of our blocks here. And then we want to actually go ahead and get the tile ID, and we want to make sure the tile ID is equal to -1, because this way we actually know that it is correct, and we can continue with actually moving the piece, right? So then what we can do is we can make our clear tetromino function here. The clear tetromino function will basically be almost the same as the render tetromino. Right, so we want to basically check every block inside of the tetromino. So we'll rename this to block to make it more sense. Then we want to remove this from the active layer. What this will do is it will actually remove the previous position where the block was, or the tetromino was, when actually moving down or moving left and right, so we don't have traces of the piece still hanging around. And actually you noticed here that we use active layer instead of board layer. Now I forgot to do this in the previous part, but we actually want to make sure we write it on the active layer and not the board layer, which is basically just only for showing the board and not actually having the pieces on it. So we want to make sure we also render it on the active layer here, like we have done right now. So that's the clear tetromino. So then basically, when we have this all set up, we have implemented our movement. So I'll show you. As you can see, it automatically moves down. I'm not doing anything. And then if I press left, we move to the left. And if I hold down, we actually move faster downwards, right? So then we also cannot collide with the walls here. Now you'll notice that we can still move it across the bottom here, but this will be something for the next tutorial. All we have to do now is implement the rotation, and that'll basically be it for this video. So let's do that right away. I'll just uncomment this because I just wanted to show you the example. And then we want to implement our rotation functionality. We'll do this, I don't know, like right here. That's a good spot. So we want our rotate tetromino right here. Then we want to check if it's a valid rotation, which is another helper function we'll make. So let's actually do that right now. is valid rotation. Now the is valid rotation will actually take nothing, so we can just skip past that. And we want to actually go ahead and get the next rotation here. And we want to use modulo 4 because we only have 4 rotations pretty much. And if it went to 5, for example, we'd get an out of bounds. So we just check with 4 here. So then we want to actually test out the rotated tetromino. So what we can do is we can get our current tetromino type and set the next rotation. And then what we want to do is we want to kind of simulate the rotation here. So for this, we can simply use the is within bounds we just used and created. So if this won't be within bounds, we simply want to return false and actually let the player know, or I mean, not even let the player know, we just simply block the possibility of going there where the player wants to go. And we just want to return true down here if it passes these checks. So then we know it's a valid rotation. So then we can come back to the rotate tetromino, where we can actually go ahead and first clear the tetromino because we actually want to remove the previous state the tetromino was in before going on with the rest and actually re-rendering the tetromino. Then we want to do the same as we did in the is valid rotation. And then we want to set the active tetromino to the actual new state the tetromino will be in. So like this. And then we can simply just re-render the tetromino like we have done plenty of times right now. There we go. And now when we actually go ahead and take a look at this, the current position is not... I actually forgot to define the current position here. I did not. What's going on? Ah, never mind. I just can't type lol. Position. There we go. Okay, so then we can rerun this code and we can see that when we press the up arrow, it'll rotate this piece like we want it. If we now want to rotate, we actually can't because it would go through the wall, right? So that way we also know if the valid rotation function is working. So we can now still not rotate because we're too close to the wall. So we can actually see that working is amazing, right? So this was pretty much it for this video. In the next one, we will be going to take a look at clearing the lines and actually detecting collisions with other pieces that we have set up right here. And then all we have to do after that is basically some UI things. And then we just want to tweak a few things to actually improve it, right? So that was it for this video. Thank you very much for watching. And with any questions, just leave them in the comments and I'll help you out. And I'll see you later. Bye bye.